Hi, I am Nikhil Sahai and welcome to Data for Entrepreneurs. If you have ever wondered how to build an AI chatbot that actually works for your startup, not just a toy bot, but something that scales, answer real questions, and speak your brand voice, then you are at the right place. AI chatbot can act like a 24/7 digital employee, one that never sleeps, never take breaks, and can instantly respond to user queries, guide new customers, and even qualify leads. For a startup, this is like adding a full-time team member without the overhead. In this video, I will walk you through a practical step-by-step framework to build your own AI chatbot using modern tools like LLM, RAG, and Google Cloud based on the same system that I use for my website. Unlike many tutorials that rely on no-code platforms or third-party chatbot tools like Tensor, Flowwise, WordPress, or ManyChat, we are going to build this from scratch using Python and FastAPI. This means you will have full control over your architecture, no vendor lock-in, and the flexibility to scale and customize your bot exactly how your business needs. And here is a key reason to stick around. Once you learn to build this yourself, you're no longer limited by third-party platforms or expensive subscriptions. You will be able to build any chatbot tailored to your unique data, logic, and goals with the confidence of a real developer. By the end of this video, you will not only understand how AI chatbot works, but how to launch one for your own business. So stick around and you won't miss this. In this video, we will be covering foundations, building chatbot step by step, where I will be covering backend integration, cloud deployment, and front-end integration. And we will wrap up with a summary. So let's get started. Let's start with foundation. We will be covering fundamentals and strategy. Before writing a single line of code, it is important to zoom out and get clear on two things: purpose and strategy. Purpose is why you are building your chatbot, and the strategy is what content it should have access to. Let's start with purpose. Is your chatbot here to answer customer questions, help user onboard faster, or support your internal team with FAQs or documents? Clarity here matters because it influences what kind of data you will connect, what tone your chatbot should use, and how you will measure its success. Now let's talk strategy. Every chatbot needs a knowledge base, that is your source of truth. It could be your website, blog post or case studies, your Google Docs or PDFs, or even structured data like order history or delivery info. We will show you how to connect all of these, but more importantly, how to structure them so that your chatbot can retrieve relevant information accurately. Because a chatbot is only as good as the content it can see. That's why we spend time upfront cleaning, chunking, and organizing your data. Now, before we jump into the backend setup, let's pause and break down three core concepts you need to understand. The first one is LLM. LLM are the large language models. This is the brain of your chatbot. It is a machine learning model trained on billions of words and documents, capable of understanding language and generating human-like responses. The second one is RAG. RAG is Retrieval Augmented Generation. This is the method that allows your bot to pull your content like your PDFs, product docs, or blog posts and combine it with LLM reasoning skills. It makes us chatbots smart and accurate. The third one is prompt engineering. This is how we instruct the LLM. It sets the tone, style, and behavior of the chatbot. Make sure it stays helpful, on topic, and aligned with your brand. Even if you are new to these terms, don't worry. We will show you examples of how they work together in the build process. Alright, purpose clarified, strategy set, concepts in place. But before we dive into the backend, let me show you how these concepts come together in action. Here is a high-level view of how your chatbot will work. A user asks a question on your website. The backend processes that question and triggers a RAG logic. The RAG engine, like Pinecone, searches your documents or knowledge base for relevant content. That content is sent to LLM like Mistral or Gemini along with the custom prompt. The LLM generates a response grounded in your content, and if the LLM fails, a fallback model kicks in. Finally, the answer is returned to the user. This is the engine behind modern AI chatbots, a smart blend of search plus generation powered by your own data. This layered setup ensures Answers are based on your content, not hallucinated. There is always a response even if your model goes down. You stay in control of what the bot says. Now that you have full picture, let's jump into the backend and bring this to life. Now the next segment is backend integration. Now that we have covered the fundamentals, it's time to start building. Since this is a core technical segment of the video, please follow these codes very carefully. Your backend is the engine of your chatbot. This is where user questions get interpreted, relevant information is retrieved, and intelligent answers are generated. So the first scene is FastAPI Setup. We will use FastAPI to build this logic. It's a lightweight, async friendly, and perfect for APIs. Let's begin with setting up your FastAPI backend. This will act as a brain of your chatbot, receiving user questions and eventually returning LLM generated answers. Here is the structure of your main file. We are importing FastAPI, request, and the base model. We will use base model to define the structure of incoming request. In this case, it just expects a prompt from the user. Next, we create the app instance using FastAPI. Right now, it returns a placeholder response, but we will plug in the LLM logic shortly. You can test this locally using tools like Postman or curl. Just send a post request with a JSON body like prompt hi, and you will get back the placeholder response. The next scene is RAG setup with Pinecone. Let's walk through how RAG, Retrieval Augmented Generation, works using Pinecone. Here is a simple flow to visualize. The user sends a question, we convert it into a vector, search the vector database, retrieve top results, and inject them into the LLM prompt. This way, the LLM generates an answer that is grounded in your actual content, not just its training data. Now we will implement this in code step by step. We will embed our content using sentence transformers, upload the vector to Pinecone with appropriate metadata, and later retrieve the most relevant chunks on demand when the user query comes in. Let's go through each step in detail. So the step 1 is chunk and embed your documents. We begin by taking your content like PDFs or blog posts and splitting it into chunks. Each chunk is embedded into a vector using pre-trained model like sentence transformers. Then we upload each of these vectors to Pinecone along with their relevant metadata, so we can later search and retrieve them efficiently. By the way, if you are just getting started, you can also use Pinecone's web dashboard to manually upload documents or vectors. That's how I initially set up things on my dataforentrepreneurs.com before moving to my programmatic uploads. Import sentence transformers and Pinecone. Load the sentence transformer model. Initialize Pinecone connection. Connect to an existing index named Chatbot index. Example chunks and IDs. These are the two small example text segments you would typically extract from documents. Convert chunks to embedding vectors using sentence transformer. Upload the vectors to Pinecone along with their metadata. So step 2 is query and retrieve the relevant content. When a user asks a question, we encode that query into a vector just like we did with our documents. Then we search Pinecone for the most relevant matches. These top matching chunks are what we will send into LLM in the next steps. Step 3 is LLM Setup. Now that our backend is ready to receive questions, let's connect it to an LLM. We will use Gemini 2.0 Pro from Google. First, go to Google AI Studio, create a project, enable the Generative Language API, and generate your API key. Install the Gemini SDK using pip. Now update your FastAPI logic to connect to Gemini. Once configured, we can use the Gemini SDK to send a simple prompt like what is the importance of data for startup and print the model's response. This helps us verify that our LLM setup is working correctly before connecting it to the full chatbot pipeline. If you see a well-formed answer printed in your console, you have successfully connected to Gemini. This is the core engine we will enhance using RAG in the next steps. So the next step is injecting RAG context into Gemini prompt. So now let's connect the loop and send our retrieval content to the LLM. We will take the top matching content results from Pinecone and join them together to form the context. Then we will build a custom prompt that includes the context and the user questions. This gives LLM a relevant foundation to generate a more accurate and grounded answer. What we are doing here is combining the search with generation. That is what RAG, Retrieval Augmented Generation, is all about. If everything works, you will get a personalized and grounded response from your content, not just models training data. So the next step is fallback strategy overview. Now let's talk briefly about the fallback strategy. Even the best LLMs like Gemini can sometimes hit limits, such as usage quotas, outages, latency issues. To handle that gracefully, we recommend setting up the fallback model. In our architecture, we use Mistral 7B hosted on Grok as a lightweight, fast backup. This way, if Gemini fails, the same question is sent to Mistral and user still gets a response. We won't go in detail for full setup in this video, but if you want a detailed implementation instructions, including routing logic, confidence scoring, and failover tracking, it is all covered in the book, the AI Chatbox Builder's Guide. So let's summarize. Let's take a moment to recap what we have built so far. We created a FastAPI backend to handle user messages and structure our input using a clear pydantic model. We integrated Gemini 2.0 Pro from Google to generate high-quality LLM responses. We connected to Pinecone using sentence transformers to implement a RAG pipeline, turning static documents into dynamic searchable context. We built a prompt injecting layer to ground our LLM answers using the user actual data. And we discussed how to handle fallbacks using a secondary model like Mistral to ensure reliability even when things fail. The backend forms the core engine of your AI chatbot. It's now intelligent, adaptable, and ready for the real-world usage. In the next segment, we will deploy this backend to the Google Cloud Run so it is accessible from anywhere and ready to power your front-end chatbot experience. So the next step is cloud deployment. Let's start with the introduction. Now that our backend is working locally, the next step is to deploy it so our users and your chatbot can access it from anywhere in the world. We will be using Google Cloud Run, which is fully managed serverless platform. It scales automatically, handles HTTPS requests out of the box, and integrates well with the tools like FastAPI and Docker. Before we continue, make sure you have installed the Google Cloud CLI, embed the required APIs like Cloud Run and Artifact Registry. If you need help with these initial setups, you will find detailed instructions in the book. Let's talk about Dockerizing your FastAPI app. To deploy a FastAPI app to the cloud, we need to package it into a Docker container. Docker lets us bundle everything, code, libraries, settings, into a single portable image. Here is what we are about to do. Write a code to define a build process, build the image locally on your machine, and push it to Google Artifact Registry so Cloud Run can access it later. Let's get started by writing a simple Docker file for your FastAPI app. Use a lightweight Python-based image. Set the working directory in the container. Copy the current project files into the container. Install required Python libraries. Start the FastAPI app with UVCon. Build and tag your Docker image. So the next step is pushing Docker image to Google Artifact Registry. Next, push it to Google Artifact Registry. Then the next step is deploying to Google Cloud Run. Now we will deploy our containerized backend to Google Cloud Run, a fully managed service that handles scaling, load balancing, and HTTPS for you out of the box. This command pushes the Docker image to Cloud Run and make it available via public HTTPS endpoint. Let's break this down. Image specifies the Docker image you just pushed to Artifact Registry. Platform Manage means Google will take care of the infrastructure. Allow unauthenticated makes your API publicly accessible, useful during testing. Set environment vars let us pass our API keys securely at runtime. For better securities in production, consider using Google Secret Manager to store your API keys instead of passing them as a plain text like this. So let's go to testing the deployed endpoint. Once deployed, Google Cloud Run will give you a public HTTPS URL for your FastAPI backend. Now you can test this endpoint using Postman, curl, or your chatbot's frontend. Let's try a quick curl command to check if it is working. If everything is working correctly, you should see a JSON response, either a placeholder message or the actual output from Gemini, depending on where you are in the build. This is a great way to verify that your backend is accessible. The environment variables are set up correctly. The pipeline from user input to LLM output is running smoothly. If you get errors, check your API keys, cost settings, and whether all the required services are enabled. A few additional add-ons for analytics and monitoring. Before we wrap up the backend deployment, let's quickly talk about some powerful add-ons you can integrate to take your chatbot to the next level. These are completely optional but highly recommended if you are preparing to go live. User interaction logs. Store every question and response in a database, example Firebase or BigQuery, to analyze the trends and improve accuracy. Feedback collection. Add thumbs or down or satisfaction scoring so users can rate your bot answers. Fallback monitoring. Tracks how often fallback models get triggered and set up alerts if it happens too frequently. Security logging. Monitor API activity to detect abuse, invalid tokens, or unauthorized access attempts. All of these improve model reliability, give you insights into how your bot performs, and help you iterate faster. We walk you through the implementation of each in detail inside the book. So check out the book if you want to go deeper. In the next segment, we connect this backend to a simple, beautiful front end that users can interact with. So the next segment is front-end integration. We are going to talk about where you should place your chatbot. Before we dive into the front-end coding, let's quickly talk about why user interface matters. A clear, intuitive chatbot interface builds trust, encourages engagement, and helps users quickly get the answer they need. Whether it's a customer on your homepage or a team member on an internal tool, the front end is where the magic happens for the user. Before building the front end, let's talk about where you want your chatbot to live. Will it be on the main page of your company website, a separate landing page for customer support, or inside an internal app for your team? Knowing this will help you choose the right tech stack and the UI design. Let's talk about choosing the right front-end stack. Now let's talk tech. Choosing the right front-end stack depends on your needs and how far you plan to scale your chatbot. If you are building a lightweight MVP or want to add a chatbot to a static website quickly, vanilla JavaScript is fast and simple. No build process, just pure HTML, CSS, and JavaScript. If you want more control, reusability, and dynamic interaction, especially for enterprise apps or SaaS platforms, React is ideal. That's what we have used for our website. And don't forget, tools like Tailwind CSS make your styling super efficient. If you're just starting and testing the idea, vanilla JavaScript works perfectly. If you're planning for growth, React is highly recommended. Now let's walk through the actual React-based chatbot that we have built for our website. This gives you a real-world look at how you can implement your front-end in a modular, maintainable way. We will cover the following in this React demo: how messages are managed using React State, how user input triggers and the backend calls, how responses are displayed using dynamic JSX, how Tailwind CSS help us quickly style the UI. Now let's walk through this React components line by line so that you can follow how it works. We start by importing React and use state hook. This hook lets us manage the messages and user input in the chatbot interface. Then we define two pieces of state: messages, which stores the conversation, and user input, which tracks what the user is typing. Then inside the send message function, we first add user's message to the conversation and reset the input box. Next, we send the user message to our backend using Fetch API. This sends a post request to our Cloud Run endpoint with the user input. Once we receive the response from the backend, we update the chatbot with bot's reply, keeping the conversation thread going. This part renders the chat window. Each message is styled differently based on whether it came from user or the bot. Blue text on the right of the user message, green on the left for bot replies. Below the message window is the input box where the user typed their messages. It is styled with tailwind for clean spacing and rounded corners. Finally, a send button triggers the send message function, which pushes the messages to the backend and updates the chat. So to wrap up, this simple component gives us a fully working chat interface styled with Tailwind, powered by your backend and 100% customizable for your needs. You can easily embed this component inside any React app or even export it as a standalone widget or to plug it into other websites. For more advanced version with typing indicators, authentications, or chat history, check out the extended guide in the book. So to wrap up what we have built so far, congratulations. You have built a full AI chatbot from scratch. You now have a complete pipeline, FastAPI backend, Gemini integration, RAG via pipeline, cloud deployment on Google Cloud Run, and a React-based frontend that user can interact with. But this is just a beginning. As you scale, here are a few things to think about next. Feedback. Add user feedback, thumb up or down to refine responses. Analytics. Log monitoring for learning and debugging. Fallback monitoring. Use fallback monitoring to catch issues early. And personalization. To personalize based on user role or context. Here is one of the security tips. Make sure to secure your API keys using tools like Google's Secret Manager. And a pro tip, set up cloud logging to monitor real-time errors and performance. For deeper dives, we walk through each of these next steps with working code inside the book. If you want a step-by-step manual that complements this video, grab a copy of the book AI Chatbot Builder Guide. You will find the free templates, updates, and bonus walkthroughs in the book. Thank you so much for watching. If you find this helpful, don't forget to like, share, and subscribe for more context on building AI-driven startup. Wishing you great success with your AI journey and see you next time. Thank you.